The difference between three-phase in transmission and three-phase in generators and motors. In transmission, the timing of the phases are 120 degrees apart, assuming conductors travel in a common direction. In generators and motors, the phases are wound 60 degrees apart. Conductors are not wound in a common direction. In transmission, the phases are perfectly balanced, so there is no combined magnetic field. In the local area of a motor, the fields are synchronized in rotation as well as time. Magnetic fields can combine. In a local area, the center phase runs 180 degrees to the other two, which flips its sine curve. Phases are 60 degrees apart. If it were wound at 120 degrees, no combined field could be produced. At 60 degrees, a combined rotating magnetic field will be produced. RMF. Each coil contributes to two counter-rotating fields simultaneously. Poles form between them where voltage is least. The vertical line on the sine curve represents the present instant in time. The green areas indicate the magnetic flux induced in the iron at this instant. The slots where magnetic flux combine are highlighted. The phases not contributing, that is, off or balanced, are shown dull. Do not think of fields in terms of bar magnets. Think of circulating fields around conductors. Poles only form in the air gap between the rotor and stator when voltage is least. If the flux is leaving the iron, we call it north. If the flux is entering the iron, we call it south. The stator fields are off or balanced. The DC rotor field is constant. Windings are made the same uniform way, but are connected in a way to form opposing fields. The series connections are crossed over at every second phase group. Each phase contributes to two fields, one from each pass through the slots. Connecting the center phase at 180 degrees synchronizes rotation of all three phases. At the start of the cycle, stator fields are balanced, the DC rotor field is constant. When star-connected, the stator flux is equivalent to a single phase of 240 volts. Then to a combined flux of 415 volts. Combined flux of 480 volts. 415 volts. 240 volts. The second half of the cycle is similar, but with voltage running the other way. Swapping any two leads changes the order that the windings are energized and reverses the direction of the motor. When connected in delta, the cycle is the same, except the voltages are based on the line voltage. At 50 cycles per second, a two-pole motor will take one cycle and run at 3000 rpm. At 50 cycles per second, a four-pole motor will take two cycles and run at 1500 rpm. At 50 cycles per second, a six-pole motor will take three cycles and run at 1000 rpm. Since retiring, I have spent time on YouTube and viewed videos on a subject that I was occupied in for over 40 years, that is three-phase rotating machinery. Some that are grossly simplified to the point of being unhelpful. A lot of videos featured three-pole motors, three monopoles at that, and imply that motors are wound with phases 120 degrees apart geometrically as well as 120 degrees in time. Some videos are very confusing, and don't understand the difference between three-phase in transmission and three-phase as wound, so I sat down and made my own. That's me on the right, making the crossover connections on a hydropower station in Tasmania about 40 years ago.